So far, we saw a number of things that we can do once we become the man in the middle. So we saw how we can see anything a target computer does on the network. So we were able to see the websites, the usernames, the passwords, the images, anything they load on their browser. We also saw that since we're the man in the middle, we're able to redirect them to other websites. So whenever they request a domain, we can redirect them to somewhere else by doing a DNS spoofing attack. Another really cool thing that we can do is modify the HTML, modify the pages as they load on the target browser. Obviously, this is all possible because we are the man in the middle, because we're able to intercept all this data. So we can wait for the HTML code, which is the code that's responsible for loading web pages. And as it flows through our computer, we can insert any piece of code that we want, and the browser will execute this code. Now, HTML is only responsible for rendering the elements that you see on the web page. So it's responsible for the buttons, for the forms, for the text. It doesn't really allow us to do much. But modern browsers can execute JavaScript code. JavaScript is a powerful programming language that we can use to do so many things. We can actually modify the whole page, remove elements or add elements into the page. We can replace links, and this is actually what I did when I modified the HSTS plugin. So I added code that will replace the HTTPS with HTTP, and I also added code that will replace the actual link, the actual domain name, with the spoofed domain name, with the one with the .corn, or to whatever you set it to in the script. You can even use it to hook the browser to other browser exploitation frameworks, which we can use to further exploit the target and even gain full control over their computer. And we'll see that later on in the course. But for now, I'm going to show you how to inject a very simple JavaScript code into the loaded pages, and then we'll build up on that in future lectures and see how powerful and useful this can be. So, right here I have my Kali machine, and before I run BetterCap and show you how to inject JavaScript, first of all, we need to have some JavaScript code to inject into the target browser. So I'm going to open a text editor, and I'm going to write a very simple JavaScript code. Like I said, we will see how we can use this to run more useful codes, but for now we're keeping this simple just to see how we can actually run JavaScript code. So all I'm going to do is alert, open a bracket, quotation mark, and I'm going to say JavaScript test. I'm going to close the quotation mark and close the bracket and add a semicolon. So right here, this code, all it's going to do is it's going to display a warning message, an alert message saying JavaScript code. So since we're going to try to inject this code into all pages, every time we load a web page, we should see a message saying JavaScript test. Now I'm going to save this. So I'm going to go to File, Save, and I'm going to put this in my root directory, and I'm just going to call it alert.js. I'm going to hit enter, and that is saved now in my root. So if I quit it, we can see we have the file right here. So this is the file that contains the code that we want to inject into any web page that loads on the target computer. The next step is to go to our HSTS hijack plugin. So as I showed you before, this was in user, share, BetterCap caplets, HSTS hijack. Make sure you use the one that I included in the resources, not the one that comes built in with BetterCap, because the built-in one will not work as you want it. So in here we have the HSTS hijack.cap file. This is the configuration file for the whole plugin. So I'm going to right click this and open it with my text editor. And in here, what we want to modify is the payloads right here. So as you can see in here, it's already injecting a JavaScript file called keylogger.js, but we also want to inject our own code. So I'm going to add a comma here, and I'm going to add star followed by a colon. we added this star right here to say that I want to inject my script into any page that the target loads. If you want to inject your code into specific domains, then you can remove the star and just list the domains that you want to inject this code in right here. But like I said, we want to inject this into all pages, so I'm going to put this as a star, and after the colon, I'm going to put the location of the JavaScript file that I want to inject into the browser. So if we look back in here, this is the file that we just created, which is in root in my home, and it's called alert.js. So I'm going to put in here, I'm just going to say / root followed by alert.js. And that's it. I'm going to save this, Control S, and quit it, Control Q, and we are ready to go. So I'm going to go to my terminal. I'm going to run bettercap using the exact same command that we've been using. So we're just giving it the interface as eth0, and we're giving it our spoof file to automatically run the ARP spoofing attack, putting us in the middle of the connection. And as you can see, this is working with no errors, so everything is perfect. What I also want to do right now is run my HSTS hijack plugin, and as you know, all we have to do is just type HS and tab. This will autocomplete. I'm gonna hit enter, and everything is running with no errors at all, so everything is perfect. And as you can see in here, it's saying that the payloads it's loading, the JavaScript payloads, are the keylogger. This is the default one that the file already was loading, and the one that we just specified, which is in root alert.js. So now, anytime our target loads any web page, whatever code we put in the alert.js should be injected in the loaded page, and it should get executed. The result of that should show us a simple message saying test JavaScript. So let's go to the target. And as usual, a good idea is just to remove the browsing data, just to make sure that nothing is cached. And I always like to first test with the simplest case and then move on to more complex scenarios. So first of all, I'm going to test it against a normal HTTP page so that there is nothing to bypass, no encryption whatsoever. So we're just going to go to vulnweb.com. And perfect, as you can see, we have an alert message in here telling us JavaScript test. So basically this means the JavaScript code in my alert.js file got injected into this page. So now that we've verified it works against normal HTTP pages, let's go ahead and test it against a page that uses HTTPS, such as stackoverflow.com. Perfect, it's working as expected. Another example would be linkedin.com. Keep in mind, these websites use HTTPS, and as you can see, we're able to load them with no HTTPS in here, so over HTTP only. So even if you log in right here, you'll be able to get the username and the password as shown before. Finally, let's go and test it against a HSTS website using the partial HSTS bypass method that I showed you. So for that to work, we'll need to go to Google first of all, and we need to go to a Google domain that does not use HSTS, similar to google.ie. This is actually the local Google website for Ireland. And as you can see, the code works. This is fine. Google only uses HTTPS anyway. But let's look for Facebook. Now we know Facebook uses HSTS, and because HSTS is used, we should not be able to inject anything on the website because the browser will only load it over HTTPS. But using our partial bypass method, if I click on Facebook from here, as you can see, the code gets executed because what we're loading right now is facebook.corn, not facebook.com. And as you can see, we get a normal Facebook page again that looks identical, and if you log in, you'll be able to get the username and the password. So as you can see, this will work against HTTP and HTTPS pages, and even HSTS if the target searches for that website, not if they put the domain name in here. So if the target comes in and literally types facebook.com manually and hit enter, the browser will force the HTTPS connection, as you can see in here, because like I said, it has a preloaded list of websites that it can only load over HTTPS. And because the browser is establishing a HTTPS connection, the data will be encrypted and therefore we won't be able to inject anything in it.